Well, welcome back 3C, and we are going to talk about transformations of parabolas. Our goal today, I know how to graph the parabola y equals x squared and how the graph is transformed when I change the equation. So we're going to look at this equation today, y equals x squared. And this is basically a way of finding points on this grid. Okay, if we know an x coordinate, then we can find a y coordinate. But I hear you saying, I don't know any x coordinates. Well, the nice thing about this is you can pick any x coordinate you want. If you pick the x coordinate of 1 million, all you have to do is sub 1 million in for x. And what this tells us is that we will take 1 million and square it, and that will give us the y value. Now, 1 million is not going to fit on here, so let's actually start with some slightly smaller numbers like -3, -2, -1, 0, 1, 2, 3. Those are just a little bit easier to work with than a million. So how are we going to figure out what y value goes with this? Well, this says that to find out the y value, I take the x value and square it. Now remember that squaring means multiplying by itself. So to figure out the y value here, I have to take -3 and square it. Well, -3 times -3, remember a negative times a negative is a positive, so this gives me +9. Now I have to do the same thing with -2. -2 squared is +4. That's -2 times -2 is +4. Let's do that again with -1. -1 times -1, well, 1 times 1 is 1, and those two negatives are going to make a +1. 0 squared, well, that's 0. 0 is real easy to work with. And then a real interesting thing happens. Notice how this is coming down, and it's not coming down in a nice fashion. Well, it's kind of nice, but it's not constant. If it was constant, this would be a line, and this is definitely not a line. This is going to look like the stuff, one of the things from the last video, which was a nice curve. But watch what happens here. It's going to start to go back up again because I'm going to square 1 and I get 1 squared is 1. 2 squared is 4 and 3 squared is 9. So it came down, but then it went right back up again. Okay, so there are our points, and I'm going to put them on the grid. Now hopefully you remember how to put them on the grid. This is now the point -3, 9. Now I hope I don't have to write all of these out that way. I'll do one more. This is the point -2, 4. Now let's remember how to put these on the grid. -3, 9 goes back 1, 2, 3 and up 9, which is going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Almost puts us off the grid, so it's right there. Now I'm going to take a little bit of a shortcut here and go down and say I know I have one at 3 and 9, so I'm just going to zoom right across here to 3 and put another one right at the same spot and kind of use the symmetry of this parabola. Okay. Now I'm going to go -2 and 4, so -2 and 4 right there. And I know that there's another one right across here at 4 as well because I've got this 2 and 4 down here. Now, -1 and 1, so -1 and 1 is here, and I know that +1 is at 1 as well, and then of course we got 0, 0 here. Now remember when we talked yesterday, we talked about the different aspects of a parabola, and we talked about the vertex and the axis of symmetry and things like that. Well, I'm just going to mention those things again. So here, and I didn't draw that very well, here, let's see if I can get that on there a little bit better. I'm just going to shift it down slightly. There, now it actually looks like it goes through the vertex, although it kind of looks like it misses some of the other points. But this is the vertex, and it's the turning point of the parabola. And of course we had the axis of symmetry that went right down through the center. Axis of sim. And this is the very basic parabola y equals x squared. So properties of the parabola, here they are, and we had them basically in the last note, but I'm going to pull them out here again. Here's the properties of the parabola. Okay, they have a lowest point or a highest point if they're upside down. This one's not upside down. The one we did in the last video is upside down. This one is actually what we consider right side up, which means it has a lowest point. And this is referred to as the max or min value. So this vertex is the max or minimum point. What's the next point that we're talking about here? Let's pull this out. The turning point is called the vertex of the parabola. Okay, I just put that on there. That the turning point where it switches from going down to going back up again. Here, I'm going to go over here. The turning point here where we're going down, 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 down. Suddenly we're going back, back, up, up, up. This turning point here, right in the very middle, is the vertex. And the last point that we're going to have on here is a parabola is symmetric. The line of symmetry is a vertical line running through the vertex called the axis of symmetry. And we already talked about that. And we talked about it in the last video too. So we're just recapping that. Now by adding things to the equation, our basic function, we can move it around the grid. So this was our basic function, the y equals x squared. So we're going to look at moving it around the grid. So I'm actually going to pull up this nice graphing calculator online called Desmos, and this is my absolute favorite graphing calculator because it is not as complicated as the graphing calculators we use in class. So here we're going to see what happens when I do this kind of thing. What happens if I take my basic function y equals x squared and I add a 2 onto the end? Well, I've already put that there. Now I just have to turn it on. Click! There, see what it did? It went from here up to here. Otherwise it looks the same. It's the same shape. It's kind of inside here, but that's because it's been slid up. So when I added 2 on the end, it went up 2 spaces. Coincidence? I don't think so, but let's do one more. X squared plus 4. Well, if this wasn't a coincidence, if we add plus 2 and it goes up 2 and that's not a coincidence, then I'm going to say that we're going to get another one up here right there. Let's see. I'm going to turn it on. Boom. Ah, I was right. Okay, there we go. So that moved up 4 spaces. So if we tack a number onto the end, it can move it up. What about if it's a negative number? What do you think? Can't hear you. Little louder now. You think it's going to move it down? Oh, that might be a good guess. Let's turn it on and see if you are right. This will go down 2 spaces. So here's our red. Our red one was our starting point. That's a very basic one. I'm going to actually go shut these ones off again. Okay, so we got our red starting point again. And let's see if this goes down. Boom! Booyah! There it is. It went down 2 spaces, and this one's going to go down 4 spaces. There we are. You are absolutely correct. So I'm just going to move over in here and say, and you've got this little thing, it's got all of them on there. You may not have them in color if you printed it in black and white, but here's what happened. Putting a number on the end moves it up and down. Putting a number on the end moves it up and down. Down, 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 down. Okay, so we're going to try something else here. I'm going to pull this back up and we're going to go to this little beauty here. And now look, let's see what happens if I put it with the x this time. Now I'm going to put a plus 2 on with the x and a plus 4 on with the x and then a minus 2 and a minus 4. And that's before we square it. I want to add something to it. Last time over here we squared our x term and then we added stuff on. Now I want to either add or take it away before I square it. So let's see what happens. Do we have any predictions here? Oh, I hear somebody say that they think this is going to move it 2 spaces. Which way? Right? You think it's going to move it from here over to here. That might actually be a good guess because if I go, usually if I add 2 to something, 2 means we go right 2 spaces. So that's not a bad guess. So you think that if I turn this one on, it may go over here. So I'm just going to turn it on and let's see. Oh! It went backwards. Oh dear. That is the opposite of what we thought it was going to do. It went backwards for some reason. I think that's one we're just going to have to commit to memory. If I put a +2 on the x before I square it, it's going to go backwards 2 spaces. What about this one? What do you think, +4? Do you think it's going to go backwards 4 spaces? Okay. Now we're catching on to here. What happens if I turn this one on? What do you think? What do you think? I'm going to turn these two off first. And then this one, well, if this one went backwards 2 spaces, this got no place to go but forward, so it's going right 2 spaces. And of course, this one's going to go right 4 spaces. And so by spaces, I mean, here's the red one was our starting point. So I'm going to take the turning point of that and see how far it takes before that lines up with the orange one. 1, 2, 3, 4. So it moved forward 4 spaces. So let's put on here. Oh, there goes my clock. Down here, we're going to say that when I tack something into the brackets, if there are brackets, it moves left and right. Left/right. Okay. Now, I have another graph over here, and I graphed this one in Desmos and just pulled it in here so we can have a look at it. This is what I typed into Desmos, and this is the graph I got. So let's take a look. We have this +3 in here, and that +3, remember this means, if there's a plus in there, it means it's going backwards because it's in the brackets. And this 4 on the end, it's got a -4, so we know that that's going down. So let's take a look. The original parabola used to have a vertex here, so now it's going this, according to this, it should go backwards 3 and down 4. So we're going to go backwards 1, 2, 3, and down 1, 2, 3, 4. And there we found it. There's our vertex. So the parabola has moved left 3 spaces and down 4 spaces. Its new vertex is at -3, -4. Now here, this is an interesting thing here. I'm going to take my handy dandy highlighter and I'm going to say, look, there's my -3, or there's a 3, opposite sign, and there's a 3, and here's a 4, and there's a 4. Okay, now notice the sign goes with it this time, where it didn't before, but I can pick the vertex right out of the equation. Okay, so for the general equation for a transformed parabola, the value in the brackets moves it left or right. The value on the end moves the parabola up or down, and the vertex of the parabola is h, k, but notice that the h has the opposite sign. See that up here we had a negative and down here h is positive, so the h has the opposite sign as in the equation. So let's describe the transformations that are happening to these parabolas. I'm going to get just a pen here and state the vertex. Let's actually do the vertex first. Here's our vertex. The vertex we get from here and here. So this is going to be 2, -7. What? Did I make a mistake? Did I make a mistake? Oh, I think you're right. I did actually make a mistake. Notice that that is a plus there, and we said that notice that h has the opposite sign as in the equation. So since this is positive here, this is negative here. Now we can actually use the vertex to tell us the transformation. This says left because it's negative, left 2, down 7. So there's our transformation of the parabola. Okay, let's have a look at this one. Let's do the vertex first. The vertex says, okay, in here, I'm going to pick that out, and it's -6. No, what? I did it again? Oh, you're right. It's the opposite sign of what's in the brackets. I'm glad somebody's watching, because boy, am I a little bit not on the ball tonight. So yeah, this was a negative in here, so that needs to be a positive in there. Now, what about the k value, though? There isn't one. There's nothing out there. Well, how do I write nothing? Well, 0. That's exactly it. So this thing is actually going, and since it's plus, that means it's going to the right 6 spaces, but nowhere up and down. So right 6 spaces is all we have to put. So I'm going to go eliminate that arrow. Now, one more here. There's no brackets. Right here, there's no brackets. That means that there's no left and right shift. So I'm going to put here no brackets, no left/right shift. And we're starting to go a little past the time that I wanted to, so I'm going to try and hurry this up a little bit. So if there's no left or right shift, then the vertex is still at 0. And we have a +5, so it means it's moved up 5. So the only transformation here has been up 5. Okay, now going over here, this says a parabola has been moved left 20 spaces. So let's write the vertex. Left 20 spaces. Remember, left is negative and 20 spaces. And then it says up 2 spaces. So up is positive and 2 spaces is like that. So there's our vertex. Now it actually says write its equation. So I need to go y equals x. And remember, we have to use the opposite sign that's right there. When it's in the brackets, we use the opposite sign. So it's going to be x plus 20. Don't forget the squared on the brackets. And then we use the +2 on the end. And one last one to try and get us in under 17 minutes. Write the equation of this parabola. To write the equation, all I need to know is what this point is. And that point looks like it's at 6. If I go over, here's 5, so it's at 6, and it's up 2 spaces, so it's at 6, 2. So here's my equation. Y equals, we get brackets, and remember in the brackets we have an x, and since this is a +6, in the brackets we have to put a -6. And here we have a 2, so we put a 2, a +2, and there's the equation. And now I suggest you go and try a few of the questions that are in the textbook. Bye-bye.